Hello friends, welcome back. Let's try to solve one more question of CN which was asked in GATE 2021. Okay, if you look at this question is something like this. Consider the computer network using a distance vector routing algorithm in its network layer. So here it's basically related with the distance vector routing algorithm. So this is the question is related to the consider the topic of OutP routing, in which we have distance vector, link stat, hierarchical, there are many different other protocols we have, but this question is related with the distance vector. Okay, the partial topology is shown below. So they have shown us some particular topology of this part. The objective is find the shortest path from R to router P and Q. Assume that R does not know initially having the shortest path to P and Q. Assume that R has having three neighboring routers denoted X, Y, and Z. During one iteration, the R measured distance of vector X, Y, and Z at 3, 2, and 5. So basically, R has mentioned that the distance of X, Y, and Z is 3, 2, and 5 respectively. Router S gets the routing vectors from the neighbors and indicate the distance from the router P. Okay, so from X, Y, Z to P is given the distance. So basically, X, Y, Z to P distance is given as 7, 6, and 5. Similarly, the routing vector also indicates the distance to router Q from routers X, Y, and Z, which is basically 4, 6, and 8. So basically, X, Y, Z to Q is basically given as 4, 6, 8. Okay, I am mentioning this 2Q from router this. So XYZ to this router's Q, we are giving this distance. Which of the following statements are true with respect to the new routing table after updation during this iteration? Okay, so this is then MSQ question. So more than one can be true, that we need to take into consideration. Okay, so let's try to find the shortest path from router R to P and Q. So we know the shortest path from router R to XYZ. Okay, we already know the router R to XYZ, what is the path, because these are all the different paths. So we can take into consideration the shortest path is this. And from each and every one of these, we also know the shortest path to both Q and P. Okay, so if we want to take the router R, which is the first router, to P. Let's try with the P first. If we want to calculate the R to P, then it's the minimum of all from R to XYZ plus XYZ to P. Okay, that means what? It will always calculate the minimum value of R to XYZ. So what is the value of R to X? R to X is 3 and X to P is basically 7. So it will take the minimum of first of all 3 plus 7, which is we are taking here 3 plus 7, which is we have taken R to X to P. Second, we take R to Y, which is 2, and Y to P, which is 6. So 2 plus 6, which is R to Y to P, and the last one is R to Z to P. R to Z is 5 and Z to P is basically 5. So basically it would be 5 plus 5, which is R to Z to P. So we are basically traveling from R to P only. This is the part. So if you look at the minimum one, the minimum is basically this, which is via Y. So the minimum is distance 8, because this will give the distance 10, this is also give 10, this is give 8 via Y. So R to P is via Y. Okay, and the distance is 8. That's what we got in the first equation. So whenever we are going to calculate from R to P, we got this. Let's try to evaluate the options here. The next hop router from R to P is Y. Yeah, that is correct, because the next hop router from R to P is via Y only. That is correct. So this one is Okay, then we have the distance from R to P will be stored as 10. No, this distance is basically 8, so this is not correct. Okay, so this is for the first point which we call. So it's basically not 10, it's basically 8. The rest is R to Q. Let's try to find the similarly the R to Q distance. So R to Q I am not writing entirely, I'm just writing minimum of what? R X Q, then R Y Q, then R to Z to Q. It means what? Minimum of what is Rx? Rx is basically what? 3, then 4, 6, 8. Okay, so 3 plus 4, if it is basically having these, this is 2 plus 6, okay, and 5 plus 8. If you look, this is will be 7, this will be 8, this will be basically 8 plus 5, 13. Okay, so this one is minimum 7 which we get via X. So R to Q will be giving this is the minimum distance. So let's try to evaluate the other two options quickly, friends. So the distance from R to Q will be stored as 7. Yeah, we can look here. The distance is basically 7. So again, this is correct. The next swap router from R to Q is Z. We can again look here. It's a basically X and not Z. So that's why this one is again false. So this is not Z. This is basically X. So we can say that here the answer is basically A comma B. It's a very simple question, friend, in which you are straightly given the distance from each of a router R to each and every router which is connected, and from that router to all the other routers. Okay, so based on this, we just need to calculate the sum of them and we need to find the minimum one. Okay, so always remember the distance vector always calculates the minimum distance, and that's what we also require. We also require the minimum distance only. Okay, so that's what it is written. It is the shortest cost path. Okay, which is given from R to P and Q. That's what the basically is required in our case. So based on that, our answer would be AN. Okay, this is a very simple question. I recommend you to kindly do practice this type of questions and these questions also. We are here with one more question of computer networks, which was asked in GATE 2021. Okay, so this question is pretty simple question. Consider a three-way handshake mechanism followed during a TCP connection establishment. So it's basically a TCP based three-way handshake mechanism. Okay, this is this particular topic on which the question is being asked here. Okay, let's try to understand the question first. Consider a three-way handshake mechanism followed during a TCP connection establishment host P and Q, between the host P and Q. So basically the host P and Q are doing a connection establishment basically. Okay, let X and Y be two random 32-bit sequence number chosen by P and Q respectively. Suppose P sends a TCP connection request to Q with a TCP segment sync bit equal to 1, sequence number X, and the acknowledgement bit equal to 0. So basically the P is sending a connection establishment, okay, with sync as 1, okay, sequence number is equal to X, and acknowledgement as 0. Okay, suppose Q accept the connection request. Which of the following choices represent the full information present in the TCP segment header that is being sent from Q to P. Now, basically, Q has accepted this particular connection request. So, first of all, P has sent a particular connection request and Q has accepted it. Okay, a very simple funda which we are doing in the case of the three-way handshaking. So, if you are not aware about the three-way handshaking, let me try to explain you a little bit here related to the three-way handshaking principle. So this happens with the TCP connection oriented mechanism. Okay, TCP connection oriented in which we are having two parties, let's say X and Y. First of all, X sends the request, then it's will sending the request plus acknowledgement of that request which is there, and this is sending the acknowledgement. Once this has been there, a secure channel, let's say a secure channel is established between X and Y. This is what? This is a secure channel which is established between X and Y and all the communication through it. Okay, so this is the concept related to the three-way handshaking basically. Now here the question, it is being asked that first of all P and Q are establishing this three-way handshaking. The P has sent a particular request in this format. We are having this sync. Sync is for the request. They are showing that it's sending the request. It's SYN. Okay. Then it's basically the sequence number. Then each and every request is having a specific sequence number. Then we are having an acknowledgement number, which is 0. Because this is only the request, we will not have any acknowledgement. And now it is telling that Q has accepted the connection request and what would be the parameters which is there. So basically the Q is currently in this piece. It would be sending this. We need to find the parameters for it. What all are the parameters for that? Okay, that's the thing which we need to find it here properly. Okay, sorry for this pen problem. Okay, let's try to identify now what all are the parameters we'll be using. As I mentioned that it is a sync and a acknowledgement. It is a sync plus acknowledgement. We are having sync plus acknowledgement. So request plus acknowledgement, both the things are there. So sync and acknowledgement, both the bits would be 1. So it would be sync and acknowledgement bit, both the bit would be 1. For sync 1, it would be sending a Y because we are telling that X and Y are two random 32-bit sequence number which is selected by P and Q. As P are using X, so this for this sequence number for sync, it will send the sequence number as Y. Okay, so let's say sync bit is 1, that's the first and the foremost rule. Acknowledgement bit is 1, that's the second rule, and the sequence number is Y. Okay, fin bit represents that the connection termination. Always fin bit is for connection termination, so it would be 0. Okay, so based on this you can check the option might be B and C. What about the acknowledgement number? See, the acknowledgement number here, just always understand the acknowledgement number here is always 1 plus previous request sequence number. Always understand this thing. So here, why we are keeping the acknowledgement number? The acknowledgement number is basically the identification of the sequence number that I am sending the acknowledgement of this sequence. Okay, there can be multiple other communication happening between P and Q. But this acknowledgement which Q is sending, it is related to this particular X sequence number. So here the acknowledgement would be X plus 1. Always understand this concept. If this particular sequence number was basically, let's say, Z, the acknowledgement number would be Z plus 1. It's always 1 plus, as I have mentioned here, it's always 1 plus the previous request sequence number on which we are responding. Okay, so if you look here properly, so your sequence number, so your basically sync and acknowledgement bit both are 1. So sync and acknowledgement is 1, sequence number is Y, and the acknowledgement number is X plus 1, and the fin bit is 0. So this would be our answer, which will be P. So always understand how is this three-way handshaking happening. So first of all, P will send a particular request. It will send the request plus the other response. Okay, or you can say acknowledgement of that request, and then after it will just send the acknowledgement, and then the secure channel is there. Okay, just understand one more thing. Let's say here it has sent a sequence number as Y. So in this acknowledgement, the acknowledgement number would be Y plus 1. So always understand this acknowledgement number would be 1 plus the last sequence number on which the acknowledgement is being sent. So here the same thing would be working out. Here the particular acknowledgement number would be 1 plus the last sequence number which is being sent on which the acknowledgement is being sent. Okay, so that's how this particular question is there. So it's a very simple question. You just need to understand how the concept of a three-way handshaking works. Okay, so kindly try to practice this question also, as it's a very simple question. So kindly try to practice as much as possible for this particular question. Let's try to solve one more question of GATE 2021, which was asked in CA. Okay, so this question is related with the cyclic redundancy check. So if you check this, it's given in the question, consider the cyclic redundancy check based error detecting scheme having the generator polynomial x cube plus x plus 1. Okay, so it's basically related with the concept of the error detection. Okay, so this is GATE 2021 based CN question. It's related with the error detection. Now here, the question is basically asked related with the generator polynomial x cube plus x plus 1. So here they had given the generator polynomial GP, which is x cube plus x plus 1. So if you are not aware, how can we calculate this generator polynomial? Let's try to identify. We can also write this as 1 into x cube plus 0 into x square plus 1 into x plus 1 into y. Okay, so from all the part, we only take the coefficients. So 1, 0, 1, and 1. So if we take all the coefficients, we get the value as 1, 0, 1, 1. This is basically binary based generator polynomial. Okay, so this is the conceptual to convert any given generator polynomial in the form of x or x cube or x raised to 4 or any format from the polynomial format to a binary format. This is how we convert them into a particular binary format. Okay. Secondly, they had given us a message which is M4, M3, M2, M1, M0, which is 11000 is to be transmitted. Suppose the message is 11000 is to be transmitted. Check bits C2, C1, C0 are appended at the end of message by the transmitter using the above CRC scheme. The transmitted bit string is denoted by M4, M3, M2, M1, M0, C2, C1, C0. The value of the check bit sequence C2, C1, C0, that is the thing which we need to find. So basically here we need to do a CRC based division to calculate the check bits. How will we do it? Let's try to identify. So the message is basically 11000, and these three are the check bits which we give by default as. Okay, so these three are basically our check bits, which is by default 0, which we give initial. Okay, this is by default 0. Now we will do the division with the GP. If we are calculating GP, GP is basically 1011. So we are doing the division by using the generating polynomial, which is 1011. And we would perform a particular XOR operation. This is basically our GP which we have calculated, and basically we need to perform the XOR operation. Let's try to identify how we will calculate. If this is of 4 bits, we need to take first 4 bits, which is 1100. The most significant bit is 1, so we will be taking 1, which is 1011 into 1 is 1011. Here we will do a particular XOR operation. Okay, so 1 and 1 is 0, 1 0. So for XOR, if you are not aware, basically 1 1 is will give me 0, 0 0 will give me 0, 0 1 will give me 1, and 1 0 will give me 1. So it's basically a bitwise XOR. 1 0 1, 0 1 1, and then 0. We always ignore the first bit, which always will get 0, and we will take the next digit 0 here. Okay, so previously we were taken 1100, now we are taking 1110. Again, the most significant bit is 1, so we directly take 1011. Again, the XOR operation would be performed here. Okay, 110, 101, 110, 011. This first 0 would be cancelled off. We will take the next 0. So now it is 1010. Again, the most significant bit is 1. So we will take here 1 and we will do 1011. Okay, again the XOR would be applied here. So 110, 000, 110, 011. The most significant bit will be removed and we will get one more 0. Now the most significant bit is 0. Till now, if you check, the most significant bit was 1, 1, 1. Even after removing the first 0, the most significant bit is 0. If you get the most significant bit as 0, we directly remove that 0, add a 0, 1, and take the next character. Okay, again, the most significant bit is 0. We directly remove that 0, add the 0 above, and add the next one. But if you see there is no next one, so finally we will get this particular answer, which is 100. So this basically is the 3-bit number, which is 100. These are your actual check bits, which is C2, C1, and C0. A very simple fundamental, which is given C2, C1, C0. So these are your actual check bits which we get. So the answer would be specifically 100. That would be your check bits. Okay, so I'm just reiterating once again, for this type of question, first of all, you should be knowing that how to convert a generator polynomial into a specific format of the binary. That's the first and the foremost thing which you need to take into consideration. Second important part is we need to know how this division happens. Okay, so 1011 and 11100. Now here they had given this is the 3 bits which is there. So always this 3 is this number 3 is always the one less than the size of this, always. So this 3 is always one less than the size of this particular generator polynomial. Even they had given this into the question directly, which is C2, C1, C0, okay, which is appended here. But even though if you haven't given it, it would be of 3 bits only. Okay, and by default we need to take this as 3 bits, which are the 3 check bits, and finally based on that we can get the final output as 100. Okay, and this XOR is pretty simple. We just need to take the 4 bits, which are whatever the number of bits we have in the GP. Okay, the same bits we need to take into consideration here. Okay, so always we do the XOR, we remove the first zero, we will get always get the first zero. If it is then the next is one, we again do the XOR. If the next bit is zero, we just remove them, and we will calculate the last. Okay, so this is the concept behind this, how we are able to do this concept related. So this is a very simple question. Kindly try to practice this question also as much as possible. Okay, friend, this is all for this video. All the best, good luck, and keep practicing these types of questions. Okay, I will also provide you this PDF. You also get this particular all the slides in terms of PDF at the end. So don't worry about it. Kindly try to practice all of these questions as much as possible. Okay, let's try to solve one more question of GATE 2021 of CN. Okay, so the question seems like consider a network using a pure Aloha medium access control protocol. So based on this, we can able to identify that this question belongs to the access control mechanisms. Okay, which is handled by the data link layer, where each frame is of length of 1000 bits. So we are having a pure Aloha based protocol in which each frame is having a length of 1000 bits. Okay. The channel transmission rate is 1 Mbps equal to 10 raised to 6 bits per second. The aggregate number of transmission across all the nodes, including new frame transmission and retransmitted frame, due to collision is modeled as Poisson ratio with the rate of 1000 frames per second. So this is the actual frames per second which is being transmitted by the system. Okay. Throughput is defined as the average number of frames successfully transmitted per second. We need to find the throughput of the network. Means how many number of frames it will successfully transmitted per second. Now how can we check this? If we identify these, the frame length. What is the length of the frame? Is basically 1000 bits. The length of the frame is 1000 bits. Okay, and the channel transmission rate, or you can say the bandwidth, is basically 10 raised to 6 bits per second. So this is your bandwidth, and this is basically your frame length. Now, if you say the frame transmission time, or you can say transmission time is 1000 upon 10 raised to 6, which is basically 1000 upon 10 raised to 6, we can say 1 millisecond. So, ideally, for transmission of one frame, we require 1 millisecond. One frame transmission, we require what? 1 millisecond. That's what the frame transmission time is there. Okay. Now, as we are using a pure Aloha based mechanism, the throughput or the efficiency in pure Aloha is basically calculated to the formula of G into e raised to minus 2g. G into e raised to minus 2g. Where basically this G is average number of frames, okay, which is actually transmitted by system or by network. You can say system or network in one frame transmission time. In one frame transmission time, dt is basically transmission time, which we had already checked that one frame transmission time is basically 1 millisecond, which is 1 millisecond. So in this 1 millisecond, which is one frame transmission time, how many frames is being transferred by the network? So we can say it is being given that the aggregate number of transmission across all the nodes is modeled as Poisson process with the rate of 1000 frames per second. So network is basically transmitting 1000 frames per second, means per 1 millisecond how many frame would be transmitted, because we are having the actually number of frame transmitted in one frame transmission time, which is 1 millisecond. So in 1 millisecond it will transmit one frame. Okay, if 1000 frame in 1 second, okay, then 1 millisecond it would be one frame. Okay, everybody able to understand this concept quite easily? Can you try to understand this scenario? G is basically the average number of frames which is actually transmitted by the system network in one frame time. So in one frame time unit, basically we are transmitting one frame. So here we can say, so in one frame transmission time, system is actually transmitting one frame, is actually transmitting one frame. This means that the value of G is equal to 1. So let's say if they are transmitting two frames in one particular frame transmission time, then the value of G would be half. Okay, but here sending per one frame transfer time or per one particular transmission time, we are sending one frame. So the value of G is basically 1 here. So here you can calculate the efficiency would be G into e raised to minus 2G, which would be basically 1 into e raised to minus 2 into not G minus 2. That's basically 1 upon 2.718 whole square. Okay, now if you calculate this value, because the value of E is basically constant, the value of E is constant, which you can take into consideration 2.71. Now if you do this particular part, you will get the value around 0.135. Okay, so this is what the efficiency is, or you can say 13.5 is the efficiency which we are having in the terms of percentage, but the efficiency is 0.135. That is what the efficiency which we are having. Now, what the question is being there? The throughput of the network. Now here we are calculating throughput is defined as the average number of frames successfully transmitted per second. So let's say we are transmitting 1000 frames per second. In that, we are having a ratio of 0.135. So we can say the average number of frames successfully transmitted in 1 second. Okay, because in 1 second we are actually transmitting how many frames? 1000 frames are transmitted in 1 second. And the efficiency, and with this particular part, the efficiency which we are getting is 0.135. So throughput for 1 second will be equal to the throughput for 1 second would be equal to 0.135 into 1000, which would be 135 actually. Okay, so basically out of 1000 frames, 135 frames is successfully transmitted in 1 second. Okay, so you can say that the answer would be 135. Okay, the throughput of the network is basically calculated with the number of frames per second. So this question is little bit lengthy, but you need to understand this formula of this G. How we have calculated this G, and the formula of G is with respect to this pure alpha. It's the average number of frames which is actually transmitted on the system network in one frame time. So in one frame time, in 1 millisecond, we are transmitting one frame. So that's why the value of G is 1. So efficiency is 0.135. Now, it's been clearly asked that the throughput is defined as the average number of frames successfully transmitted per second. So we are sending 1000 frames per second. So we need to multiply that efficiency with 1000. So this would be our answer, which is 135. So this question is little bit complex and little bit lengthy, but kindly try to understand this question purely well. Okay, so these are the questions related with the computer networks in GATE 2021. Kindly try to practice these questions as much as possible, because these questions tend to be little bit difficult and little bit complex also with respect to computer networks. Okay, so this is all for this video, friends. Thank you, everybody. All the best and good luck. Keep practicing the important questions. Very, very good luck to all.